Last year, I was browsing around many security conferences, and basically I started chat with folk from security with kind of questions. Are the terms safety and security synonyms? Yes, and if the answer was no, I'm not sure, I ask, okay, what's the difference? Okay, simple question. And the result is, if you speak to the folks from ATMs, servers, network security, say game consoles or endpoints, they all say we are synonyms. Especially if you speak to the English native speakers, they all say it's synonyms. The ones who were unsure, we just were expecting a catch, right? If you ask something, people expect something. So if you speak to the people from railway, avionics, automotive, industrial automations, in all the cases, in almost all cases, people say, no, we're not synonyms. So let's start first to think about the definitions. And safety, so how I define it, this is when system shall not harm the environment. So example, we have an aircraft, this is a system, environment are the passengers, and the simple fact is, system shall not kill passengers. So this is safety system. For security, we say environment shall not be able to harm the system. So, for example, we have some data stored in a device, and then the bad guys should not be able to get to this device. So we have the safety, this is from the systems to the outside to the environment, and security, this is from the environment into the system. And now we say, okay, but now we have these two terms, inward, outward. So how these relate to each other? So my first claim is security is not a product. So you cannot sell it. I mean, it doesn't exist. Security as a standalone cannot exist. If there is no function, it's secure by definition. Nothing happens. It's secure. So security is always needed for something. So, for example, for function, for computation, or for safety. Simple example, we have encrypted communications. What would be the prime functionality of encrypted communication? Any guess or any suggestion? Exactly. It's communication. I want to speak, so Alice and Bob, so security terms. Alice and Bob want to speak to each other. They don't care about encryption. Only because there is if, we want to encrypt. And then you introduce encryption to communication channels, you have to think about it, okay, what does it mean? Will it introduce additional jitters, delays, or maybe some PKI or whatever key infrastructure is needed. So and then you have to either say we don't need security, or you have to rethink how your safety functionality, what is in this case exchanging data, can be combined with a security feature, which is encryption. So diving deeper, so the question is how we can achieve security, how we can achieve safety, and how we can achieve both of them things simultaneously. So nowadays, if we ask, okay, what we do for security, and the people say, okay, we do some checks, we do filter, we do check again, we use anti-something, we do cryptography, or we create a lot of logs, we analyze the logs, we protect the key, PKI, and maybe tap device. We do network analysis, pen testing, surface attack analysis, maybe some regular vulnerability analysis for product in the field or in a lab, and maybe sometimes, very seldom, people do security certification. So and this is where I say, my personal opinion is how at the bottom people really seldom apply it. It's maybe too expensive, but you have a lot of gain from security perspective. And at the top, this is where you got less gain, but it's cheap and it's quick. How you usually achieve safety? So you start with a system functionality like, okay, can your system speak about a hard and real and soft real time or deadlines? What about fault tolerance? What about redundancy, dissimilarity of a software design or software hardware design? How do you define explicit safety domains? What the quality assurance? So how you develop the software, how you specify software, how you design your software. Do you have a development process? So the output of this process is so the probability is higher that it's what you specified. Do you do reviews for test cases, for test results, for the source code? Do you test? How do you test? What is the test coverage? So you do a lot of different analysis. For example, what is the worst case execution time of your code? Do you do a partitioning analysis? How data, which are just data for number crunching or data for decision takings, how you do separate them? You have may apply formal methods on a design level, how resources are consumed, scheduling analysis, and so on. There is also such a Today somebody call it a pain in the ass. I think it was the guy from the Schneider Electric. Yeah, it's a third-party assurance. So it may be pain in the ass. I've thought it as well when I started in this domain. But now I say, there are some use cases where I really want to have it. And it's basically a risk-based analysis where you say, if we go for the certification, then the probability that the product does what it's claimed to do is higher. And there are different standards. For example, in avionics, you have DO 178. In automotive, you have ISO 26262, and so on and so forth. So the question is, okay, where is safety on this? So on this security, different functionalities. And the answer is, okay, but do you think about bounded execution, delays, jitters? What is the code quality of this particular security product? What about the runtime of the algorithm? So you have the database of huge, I don't know, number of some signatures or whatever, and your algorithm depends on the length of the database, but you never really know how big is your database, and you miss all the deadlines which are needed to say to steer a critical system like an aircraft. So, and how it's about safety certification. So today I see that a lot of products which are branded as a security only, we rather try to at the moment not to address these issues. It's rather like a product, it's nice, it runs, but we don't go deep enough. So the question is how we can provide trustworthiness for security, so we can really, this product is not just trusted as now, so we just believe in this product, what it does, but it's trustworthy, so there is enough reasons to believe it, and without compromising on safety functionality. Solution one, do for anything which is about the security is the same what you do for safety. I mean, it's simple, but probably you don't want to do it. I mean, then you just explode, you have to pay at least double. Then another solution would be, okay, maybe you need a platform. So here it's called the Meals platform. I will explain later what is Meals, where you can run safely critical applications, critical safety and security applications. You can run your security application safely, so it's your security applications do not interfere with the safety one. So you have guarantees that there are no these interferences. You have effect what security doesn't affect safety. For example, time it's a good example. But you have certification domains and scopes. So if you have one piece of which is certified and it's critical, it's your code which is maybe not certified can run on side by side, and you can rely on the platform's evidences for this separation. So basically, it's how to design and assure that safety and security, in this case, they will be independent. So you mic, divido, and tempera. And you cannot really do it in modeling composable way. So the question is, of course, what kind of system do I mean when I say safety and security? For example, systems like this. This is an aircraft, and with the security domains in an aircraft is they defined in a RINC 811. You see the reference. This is security and trust, security in airborne devices, basically. And this is how the domains look like. You have crew domain, so that basically the cabin and the stewardess are in this domain, so we can interact with some systems like cabin core systems or flight support. You have passenger domains where you can connect to the internet and partially connect to the aircraft when the captain's speaking. You have maintenance, so we had already talked today about how maintenance can be critical. In a aircraft, you have to maintain a lot of systems, and sometimes you really don't know who exactly connect to the aircraft. So it can be somewhere, I don't know, in Bangladesh or whatever. Then you have all other services communicating with the air traffic control and airline services. So this is a huge machine, it's flying, it's communicating, and since 10 years it's already connected to the internet. So this is one of the example how the things could look like. This is A400M, a military transport aircraft developed by Airbus. We have, so this is a cargo, it has carry some payload. And there is a systems where you have applications which, so level B, it's the second highest level in certification, and level D, this is the second lowest level certification. And level B applications, it's to open the ramp, to open the doors, to start aeronaut delivery. So you have to kind of to throw the cargo. And also level B application would be graphics. This is an OpenGL. This is HMI control. And level C, you have different winches and crane. And level D, there are applications like waste and water and so on. And all these things we run on the same platform, on the same device, on the same operating system. So another example, automotive. So now we know that there are a lot of different ECUs, and we are extremely we have extreme density of functionality. For example, like instrument cluster, you have connectivity box, infotainment devices. Again, what we have here, you have one hardware, one operating system. You have Android, which is connected to whatever it wants to be connected, some to the cloud. You have, say, AutoZAR. AutoZAR is a specific automotive application environment, which is standardized. So, and it usually have access to the CAN bus. What you want to avoid, that stuff which runs in Android partition, for example, with navigation, does not interfere with applications accessing the CAN bus. For example, showing the status of the car, showing the status of brakes, and so on. Maybe you also don't want that it does not interfere with early applications, like if you start the car, people expect that within 2 seconds something happens. And for example, you're in a parking spot, you want to actually to drive out. So this is the safety and security examples of the systems. So this, what kind of trends we have with functionality density is increased. We have a lot of functionality running on even less number of devices. So here we need separation and control of functionalities. We have heterogeneous information flows. So CAN bus, Wi-Fi, 3G, we have different criticalities, but they usually intersect somewhere. So you have to think about separation of information flows. And last but not least, you have to provide assurance why your system is trustworthy for both safety, so it functions correctly as you claim it, and security, so the system cannot be damaged from the outside. Yeah, and somebody has to pay for it. So don't forget it. And these trends, they are applicable in all domains. Whatever you look like, industrial automation, railway automation, communication devices, satellites, submarines, you have the same. We take the COTS hardware, we take COTS operating system, we put a lot of functions, and we hope the thing works. So now I will not present you any hacks. This is rather what you can do or how you can build a secure system. So one is what kind of challenges we are solving here. And if we integrate a lot of functions on one device, first of all, we have resource sharing. And resources are CPUs, memory, I/O memory, files, drivers, device, buses, so everything what you have on the device or represented by operating system to application. From safety, you have requirements on integrity of data. For example, availability, that CPU is there to compute. You have isolation of application errors. You have some fail-safe operations. And from security, you have additionally confidentiality issues, possible side channels attacks via shared resources, for example, logs or some APIs. And since this is not a static system, it executes in a time, you also share time. So you cannot avoid share time. Applications will run simultaneously, more or less. And you share CPU cycles and different time effects on shared resources like memory buses. You have, again, safety issues like availability of time or of resource, deterministic behavior, meeting all the deadlines, the right balance between event-triggered and time-triggered tasks. So you have a periodic task, it would be time-triggered, or you have an event task. I don't have power, so I have to do something. So this would be an event-triggered task. And from security, again, you have all different attacks on a time, on, so for example, on buses. So time itself is an attack surface. And here you need something which will allows you to partition resources and partition time into different safety and security domains. So here, so how it's we develop system, you have different applications with different criticalities, and they should work together somehow. And you also need to bring an execution platform. So this is a design which people usually draw on the high level. But once you have a platform, then the platform has properties. These properties interfere with your designs. They restrict your design, so you have to consider it somehow. And generic problem here, how to refine such a design with a platform, what I don't have as a system designer to mess around with effects or arguing about this platform. And one of the approaches is in a community is to use meals, and it is this is a high assurance security architecture, so it's not a product, it's a concept that supports coexistence of trusted and untrusted application on the same platform. It relies heavily on the verifiable separation mechanism. So there is some kernel which is verifiable, and we can generate trustworthiness, and on controlled information flow between applications. So we have this, we refine, so we add a platform, and this platform provides set of properties, so we can actually argue about different domains. So, and the idea is that if you have such a meals platform, then you as a designer or as a security analyst can focus on what you do best on applications. So you focus on security of these applications, on security on application layer security, how this application exchange data, what kind of application protocols use. You don't think about then CPU and the memory buses, do I protect all the I/O areas and so on. So what would be possible? So if we have such a system, then we can actually stack the safety and security. So we have hardware, operating system, applications, and it looks like a T. And the assurance case for assurance case, this is what you have to develop in for your safety critical system. What interactions on application infrastructure levels, assurance case for absence or mitigation of interferences or site or recover channels on the infrastructure level, and assurance case for execution platform, it's already covered by the meals platform. So again, here you see you can focus on applications, how to make these applications work together, what kind of protocol they have to exchange. And we have spoken about the maintenance of devices, how to update them. And if you have a safety critical device or which controlling some process when the things can explode wherever, you need to update it. And here actually you can update it. So if you have a nicely defined and trustworthy environment which with proven non-interference, so you can easily replace one application with another application. So this could be kind of a secure update. But in this case, it's not like a patching. It's you can do it sometimes during a running system which still controlling a critical process. So you can update it. So this is different standards in different domains, and I have no time. I jump over the slides, but the main takeaways from my presentation is I would just say that the most important security measure in your system is the architecture. So this is not cryptography or whatever. So you have to, the concept how you integrate the platform, how you integrate applications, how we work with each other. This is the most important security feature. If you mess around here, it's basically it. So it's vulnerable. Okay, thank you.